I want to define for you a couple of terms that will be extremely useful this semester, and then I'm going to go back to my whiteboard and we're going to talk about membrane potential in a little more detail. The first term you need to know is this term of resting membrane potential. And the name resting can be a little bit deceiving in that it sometimes causes students to think that the cell is just sitting there doing nothing, which is not true at all. If we take a look over here at this neuron, you can see in here we've got our endoplasmic reticulum with my ribosomes all over here. We've got a mitochondria right here. Of course, the nucleus. Here's my Golgi apparatus. And so this cell, even during its resting phase, is very busy. It's synthesizing proteins. So we definitely got protein synthesis going on. And it's doing a whole bunch of other things. Synthesis. Anyway. All right, we're just going to leave that alone. And so the resting membrane potential, what this word really means is that this electrical cell, so it is capable of generating these bursts of electricity, and we'll get into exactly what that is in a later section. But these bursts of electricity are periodically produced. But the in-between time, where it's not actively creating a burst of electricity, we say that the cell is at rest. And we talk about it as being the resting membrane potential, which means we're essentially, we have this difference in charge across the cell membrane. We've got an abundance of positive charges in the extracellular fluid, abundance of negative charges in the intracellular fluid. And I want to make sure you notice this. We do have some positive charges here too. It's just a question of abundance. The negative charges are more numerous in the intracellular fluid, and the positive charges are more numerous in the extracellular fluid. But that doesn't mean we don't have negatives and positives in both spaces. Okay. Sometimes, by the way, I tend to talk about fluid compartments. And I just mentally, it's a mental game that I have found useful where we talk about these fluid compartments. The extracellular fluid would be a fluid compartment. The intracellular fluid would be a fluid compartment. And so we discuss, I use that terminology from time to time, so you should be aware of that. And so at rest, this is essentially what we're doing. We're sitting here with this difference in charge, and the charges are stuck. They're both stuck wherever they are. So the net positive charge is in the extracellular fluid, the net negative charge is in the intracellular fluid. But when the cell begins to generate a electrical signal, there are two types of electrical signals that we need to be aware of. The first is this one, and this one is my graded potential. Okay, and my graded potential is generally generated in a few locations. It'll be generated out here in the dendrites. It can be generated in here in the cell body. And ultimately, the graded potential that we care the most about, that is going to have the greatest effect on the cell and whether or not the cell generates this burst of electricity that we've been talking about, is the graded potential that reaches this location right here. And this location is called the axon hillock. And in this axon hillock, typically right around here-ish, okay, we have this zone called the trigger zone. And we'll discuss both of these in more detail a little later. For right now, I want you to be aware of that. Now, what is this graded potential? Well, let's go back up here. A graded potential is created when we have a temporary, I guess we'll do blue. The temporary opening, and I'm going to walk you through this on a whiteboard. We're going to get a lot more detailed on this because it's important to understand and to know. But if you have a channel in this membrane, an ion channel in this membrane, and it temporarily opens, what ends up happening is you get this temporary movement of positive charges into the intracellular space. And those positive charges essentially neutralize some, but not all, of those negative charges. And because we're dealing with ions, these ions, the laws of nature, of course, apply to ions, and diffusion is a force that occurs. We're moving from a concentration gradient. So here's a high concentration of positive charges right there by the ion, but they're not going to just hang out there. They're going to start to diffuse. And as long as we have this channel open, more positive charges will come in, and they're going to spread out within this localized space, diffusing to different locations and spreading out. Now these ion channels don't stay open forever though. So as soon as this ion channel goes back to being closed, so we'll just go ahead and color it in like this, so now it's closed, we no longer can supply those ion channels, and they eventually, supply the positive charges, and they eventually just spread out and are diluted thanks to diffusion. And then we also have our sodium and potassium pump, which will return those positive charges back to the extracellular space. There's going to be more on that in a bit. But this local graded change in electrical potential in a localized region of the cell membrane caused by the opening of these ion channels is what we call our graded potential. It's just a temporary localized change. And so that change can be both positive or negative. It really depends on the channel. If we open up a channel that allows positive ions into the cell, we get a positive graded potential. And I'll talk more about these in a little bit. I'm going to give you some additional vocabulary words and terminology, but for right now we're keeping it very basic and very simple. And if you open up an ion channel that allows negative charges into the cell, we get a negative or inhibitory graded potential. And we can accomplish this in another way. We'll get into the nuts and bolts of that soon. But for right now, these are the definitions. Now, I mentioned this trigger zone. Depending on the type of graded potential that we have and how strong of a graded potential we have, we might, and there's no guarantee, but we might generate the other potential that I want you to know. We're going to have a lot of vocabulary words that have the word potential in it. But that's this action potential here. And when I talk about bursts of electricity, essentially that's what I'm talking about here. This electrical current, just like the current that runs through the wires in your wall. And this electrical current is generated in the trigger zone or by the trigger zone in the axon hillock, and it will travel in one direction and one direction only. It travels away from the cell body to the nerve terminals. It only is produced if there's a sufficiently large positive graded potential. And we're going to look at all of these details in just a little bit. But let's go ahead and go to the whiteboard for our next video.